Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. I've got, I guess, good news and bad news. Hey, Gathros, what is up? The good news is we are streaming today. The bad news is we're not streaming for as long as I would like. I was hoping to have a bit of a longer stream today from 5 to maybe 9 o'clock a.m. my time, a 4-hour stream, which would be twice as long as normal. And I was hoping that during this stream we could completely finish our fractal Christmas tree that we were hoping to create. But unfortunately, we are going to have a planned power outage today in my apartment complex from basically 10 a.m. until 4 o'clock p.m. Which means if I stay any longer than basically 7, I'm not going to be able to prepare everything I need so that when I go to campus, I can get all the work done I need to get done today. So basically, I need to finish rendering the video, upload it, and basically have that ready to go so that when I go to campus, I can finish working on the algorithm archive content. So there's just a lot of stuff I have to do in the background there for the Gaussian elimination video to go out tomorrow. But it is how it is, you know. So unfortunately, today, instead of being one long video where we do, all of the fractal Christmas tree, we're going to have to do kind of a series throughout the upcoming week, which is unfortunate, but it is what it is. That also said, tomorrow is still going to be a GPU day. I'm not exactly sure what we're doing tomorrow. I think we might be using the QFFT library or something like this. I haven't quite decided the best thing to do, but we'll see. I'm going to look through the exercises and stuff that we've done before and see what the best thing to do is from there. Yeah, it's a planned power outage. It is weird that we have them. Like, I never had them in my old, where I used to live in the US. But for some reason here, we always have planned power outages over the weekend once per, I think maybe season. I think maybe there was one, I know that there's one over the winter every year, and I feel like there's one over the summer every year too. I'm not really sure, it happens every now and again, and I always forget when it's going to happen until like the day before. And then the day before, I'm like, oh crap, tomorrow I'm gonna have to work. Like I'm gonna have to go into work all day. But it's fine, it is what it is. It's not that big of a deal. Now, as far as today's stream is concerned, let's go ahead and go over here and go to twitter.com. And I'm going to go to my own profile. And let's just go to this poll over here. So the other day, I did a poll on twitter.com. If you're not following me, please go ahead and follow me on twitter.com. The point is, I did this poll where we basically said, hey, we're going to draw Christmas trees over the weekend. What type of Christmas tree would you like to draw? And people were like, hey, we had ASCII, Fractal, and Parametric, and most people said Fractal. Oh, Gather, thank you so much for resubscribing for 8 months. That is 1, 2, 3, 4, 5, 6, 7, 8. Wait, is that 9 Simucows? One second. 1, 2, 3, 4, 5, 6, 7, 8 Simucows. Nice. Thank you so much for the subscription, man. I really do appreciate it. I mean, I don't know what to say. I want to ASCII, but I don't have Twitter. We can add another vote to ASCII. I also wanted ASCII. Why not L system tree? I didn't put it down. I mean, that would be under other, which would have been very interesting. But yeah, so most people voted for Fractal. I really was gunning. Ooh, I'm sorry, I hit the microphone. I was also gunning for ASCII. But it is what it is, you know? I'm not too worried about it. And I'm hoping that what we do today will turn out pretty cool. Basically, I'm going to try Fractal first. If it ends up being that the Fractal doesn't make any sense and it's impossible to do what we want to do, fine, fair enough. We'll do something else, you know? But I really wanted to do like this animated ASCII Christmas tree type of thing. I don't know, I just like where we have like, maybe like little twinkling lights and stuff like that. That'd be really cool. The Fractal Flame one is the only one that's not animated. Like if we do the parametric one, which is basically, creating a Christmas tree with some sort of set of equations, we can very easily make this time dependent and have it like rotating or something like this, but we can't do that with the Fractal Flame one. It is what it is. It's a Fractal Flame, you know? So it's okay though. We'll see how it goes. Oh, also there's another thing I wanted to point out. The paper that I was discussing a while ago is here. So we just recently got it in the archive. So if you're interested in chaotic few vortex dynamics and rotating Bose-Einstein condensates, please feel free to check that out. That's the most recent research paper that I've kind of put out there. So this is research paper number 3 for me. Although I'm not sure if the Journal of Open Source Software paper is yet on my Google Scholar. Let me check something. Oops. Let me see. It's on my Orchid, but I'm not sure about Google Scholar yet. It might not be on Google Scholar. Yeah, it's not there yet, but that's okay. We'll get there. Yeah, I need more research papers. I understand. Don't judge me. All right, let me get some water real quick, and then we'll go ahead and get started on the fractal stuff. Unless there's something else you guys want to talk about first. Yeah. Let me get some water. I guess the only other thing I want to point out is that I'm sorry about being so inconsistent last week. It's just because I was working on the paper, I just kind of crashed once the paper was out because I just had so much stuff I had to get done, and I don't know, I didn't do very well after it was out. I just kind of went home and went to sleep. Have you seen the Dynamic Windows Manager DWM? It looks cool. Oh yeah, I have seen DWM. It is tiling, right? So the thing is, I haven't used a tiling Windows Manager before, and so I was kind of afraid to use it. But yeah, it's quite good. I am a big fan. Oh, sorry. I'm a fan of the aesthetic. Like this looks really nice to me. I'm just not used to it, you know? Oh, I guess it's not tiling, is it? It has to be free floating. Man, every time I look at it, it just looks so nice though. Yeah, like if I could get mine to look like this, man, that would be so cool. But I like the way that mine looks currently. Ah, it's dynamic, so it's both tiling and floating. Huh. I like that though. That looks really nice. I should probably do more than what I'm currently doing for my my desktop. Like honestly, it is something that people look at every day, you know? So maybe I should try to make it look more aesthetically pleasing. I do like the way it looks though. I mean, there's something to be said about it. It's simplicity, you know? It's just a desktop background with, you know, a very basic toolbar and some ASCII terminals on the side, you know? There isn't really much more to it. What I was thinking about doing is developing my own Windows Manager. Now, hear me out here, because this might sound really dumb. You need a new wallpaper. Yeah, I could do a new wallpaper. I don't mind. I mean, I just like the simplicity of it. It's super simple, not a big deal. But I was thinking about developing my own Windows Manager, you know? That is essentially a tiling Windows Manager, where the desktop is a terminal, you know what I'm saying? So there is no desktop. It's just a large terminal that you can segment in different ways that you want. So like you can make it, you know, you can do whatever you want with it. And the tiling nature of it comes in that Windows Manager there. And then I could do, yeah, spherical cover the wallpaper. We'll see how that goes because we're still working on the redesign there. But yeah, so I was thinking about doing something like that, where it's basically just a giant terminal that sometimes pulls up UIs if necessary. Otherwise, it doesn't. Oh, hey, Trash Talk. Cognosama Gathros, thanks so much for coming in. I realized I didn't say hi to everyone. I don't know, stuff that I've been considering. I've always wanted to get into more like Linux development, you know what I mean? Like just development of different apps and stuff that people might or might not use. And to me, the most aesthetically pleasing thing I can think of is something like ASCII. I don't know why, I'm just really drawn to ASCII images and ASCII art. I don't know why, it's just, I always have been. It's just, every time I see like an ASCII, like every time I look at ASCII Aquarium, like this guy, I'm always just blown away by it. It's so cool. I mean, not every time I look at it, but like, man, it's so cool. And like, don't get me wrong, I understand that like there's some animatory animation effects that you can't get in ASCII. But just look at that, like this guy has a little spout. Leos OS plus Leos Windows Manager is greater than Arch Linux. Yeah, I don't know about that. Like the Leos operating system isn't going to be too. I mean, don't get me wrong. Like we have a working prototype of the Leos operating system developed by this guy named Gathros. It's pretty cool, but it's maybe not able to do all of the things that a Linux desktop can do. Okay, let's go ahead and clear here. And let's CD into project Simuleos. Ooh, that's not right. Simuleos. Let's go. And let's here and CD into Fractal. LS. CD into projects. Project. Simuleos. Fractal. Ah, that's relationships. I don't have a relationship. Fractal. Let's go. Man, I cannot type today. Oh my gosh. Alright, so let's see what we have here. I'm going to just look at what we have. So let me go into MirageYo.png. Ah, here's the Barnsley Fern. Aha, there's our little heart fractal flame. That doesn't look so bad. There is, of course, the woman that we always do fractals of. What is this? What am I even looking at? Okay, well, nice. I'm glad I took the time to do this one. Oh, this must be when I was checking to see if we can bin the data into a PNG file. Oh man, good times, good times. So here, let me just go ahead and talk about what we're going to be doing today. So I asked, and a lot of people wanted to do a fractal Christmas tree. Now here's the thing. We can do a fractal Christmas tree. This is literally just the Barnsley fern. Don't get me wrong, we did this for ThinkerCon, and it was okay, you know? Like, based on how we do the Barnsley fern, we can actually pretty easily generate a whole bunch of points that, you know, look like just basically a whole bunch of glowing dots, you know? So basically the idea would be that we generate Barnsley fern, and we generate, we plot like 100,000 points at a time, and by plotting 100,000 points at a time, we can get this Barnsley fern that kind of, you know, flashes, flashes blue, then green, then gold, then pink. Because basically we're plotting every 100,000 points and it changes color every 100,000 points. And that's pretty cool, right? So we can get something that looks kind of Christmas tree-like just from doing that. And that's not very hard. That's super easy to do. In fact, we can modify that probably on Monday to do that if we wanted to. It wouldn't be too hard to do. I just needed to copy the visualization scripts over, which I don't think I currently have. Let me do a quick get status, get branch. Of course, get status does nothing, so let's go ahead and clear, get pull, origin master. That's not how you spell origin. Let's try this again, typing properly. Layups OS is extremely lightweight though. That is genuinely true, yeah. Yes, I don't have the right plotting functions. But we have everything basically that we need here, so we're okay to go. As far as the ThinkerCon stuff is concerned, I'm thinking here's what we're gonna do. So for the video, I'm gonna start by saying that during ThinkerCon, we I worked with Dan Schiffman to do a live coding presentation in front of a live studio audience, and being the inferior coder, he beat the snot out of me. So here's my attempt to do a little bit better, or something like this. And so basically describing what we did during ThinkerCon and explaining that at ThinkerCon, we kind of realized that this looks a bit like a Christmas tree. And so we thought that in the spirit of the Christmas season, or I thought that in the spirit of the Christmas season, we can redo this fractal Christmas tree to make it a bit more Christmassy and a bit less, well, like, not Christmassy, like just make it more Christmassy and stuff like that. So this is gonna be one of my first attempts to really make a seasonal video. I've never really done a seasonal video before. Like, don't get me wrong, like the Valentine's Day video was a bit seasonal, but I mean, at the same time, it was kind of like, it wasn't really like for Valentine's Day. It was just kind of like a joke date type of thing, so it wasn't dated. This one is actually kind of like dated. It is Christmas trees. It has to be done during Christmas. So it has to be done over this upcoming week. And that's kind of what I'm going to be shooting for. Okay, so let's talk about what we're actually doing here. Less weed, more tree, gotcha. I'm really tired today, guys. I don't know if you could tell. Okay, so let's talk about the fractal flame algorithm. So as you guys know, or as you guys might be aware, there's this thing called called iterative function systems. Let me just go ahead and look this up. Iterative function systems. Oh, come on, dog. Systems. Let's go. Spell something correct today. You've spelled not a single word correct. Iterative function systems. Okay, so these are things with chaos games inside of them. So the chaos games are kind of like, I don't really know how to put this. They are, basically you've got a function that you iterate through. So you have some function that allows you to do one of maybe 3 or 4 actions, right? And you choose which of these actions you want to do at random. And by basically choosing these actions at complete random, you're able to generate real patterns. And that's kind of neat. I'm going crazy, guys. Help me. I'm so sorry, Buttercake. Why are you going crazy? You should do more collabs like that date thing. Yeah, I really wish I could. The day is still young, Simulators. Look, it's literally 5:30 in the morning, so it is incredibly young for me, and I'm so incredibly tired. No, but seriously, what's wrong? I'm actually kind of worried. The new Vsauce curiosity box has a wooden puzzle in it. Oh. Well, okay. What's wrong with a wooden puzzle? I can't solve it. Usually only needs 5 to 10 minutes. Oh. Oh. Ha. I'm so sorry. I cannot help with that at all. I'm horrible with puzzles. So anyway, yeah, so the idea here is that we're working with these iterative function systems. Now, the other thing here, let me look for chaos game. Oh, chaos. Ah, here it is. These are closely related to chaos games. Chaos games are basically, how do I put this? Chaos games are basically, you know how I said we have these iterative function systems that choose randomly between different functions? The chaos game is the thing that chooses between the functions. It's called chaos because it's, I don't know, it's just random. I guess I should have a better excuse for why it's called a chaos game, but it is called a chaos game. I'm sorry, Buttercake, I can't help either. Have you tried an electric saw? I thought you guys were smart. Man, have you seen this channel before? Because like that is totally wrong. At least, you know, I'm not smart. I don't know. There are people in the channel that are smart, but I'm not. No, just ask Gustorn. He knows everything. That's my go-to whenever people, not Vsauce smart. Whenever people ask how to do something, I'm always just like, yeah, I just ask Gustorn. He knows. All right. Nice. So we're kind of working with these iterative function systems, and the idea is that we're working on something in particular called the fractal flame method. So let's look at the fractal flame. I believe, let me see, that's one of them. Let me do a quick ls here. No, we don't have it over here. So let me go ahead and do fractal flame, and let me see if I can find the appropriate PDF that I'm looking for here, actually. Probably should have looked at this beforehand. Oh, I'm sorry for the yawn. Paper, Lego, fractal flame algorithm. This has to be it, right? Like it's a PDF about fractal flames. Boom, look at that. Fractal flame PDF. Even in uni. Yeah. Okay, so the fractal flame method. See, look at these guys. There has to be a way to make a fractal Christmas tree with this. I mean, it just looks so nice. The fractal flame method is basically a play off the iterative function systems that we said before. I did really hard physics and math. Okay, maybe not. Maybe this isn't quite what I do. But yeah, so it pulls off of the iterative function systems that we have before. Basically in that we have a bunch of different variations, and we choose between these variations in order to create our fractal flame. Now there's a bunch of other things that we do here, like for example, in order to create our IFS fractal, we end up having a whole bunch of points that we use, like millions of points. And so what we do is we generate these millions of points, and then after generating these millions of points, we bin them into very particular images. And after binning them into images, we then create something that looks like, well, a PNG file that we can then color and stuff like that. Now, one interesting thing that we could do, and I'm really tossing this up, and I'm thinking that maybe we should try it, is tomorrow we could try to generate our IFS system on our GPU. And so we could try to use Julia GPU, which I've never really tried before, but I think would be a nice thing to try. So we could try Julia GPU to do this tomorrow. Wait, what? I did a thing? I moved a bit that I didn't move before? Hey James, I've been wondering about this quantum noise, I'm assuming noise, in the Einstein-Bose condensate. Just ask Gustorn. Yeah, I mean, that's just been my research. Have you seen, here, like, I just showed you guys my research paper that we recently put out. I didn't show you the PDF, though. So if you actually click on the PDF, it says, just ask Gustorn. Like, that's the entire PDF. It's just, we have an abstract and everything, but if you go down to the reference section, it's just like, yeah, just ask Gustorn. Hey Isley, what's up? How are you? We helped, right? Leo's community is greater than the Vsauce community? Obviously, because Buttercake can solve this puzzle. If Buttercake is unable to solve this puzzle, then our community is not better than Vsauce, so we have to show that we are somehow better. Yeah, but actually, this is the paper that we were working on. Again, if you're interested in chaotic few vortex dynamics and rotating Bose-Einstein condensates, yep, that's what I spent time on. I can talk about it more, but this isn't the point of today's episode. We can talk about it later. Okay. The pressure? There is no pressure. No pressure at all. Hey Lordborn, I feel like I feel like it's been a while since I've seen you, Lordborn, but I don't think that's true. I think you were on not too long ago. I think it's just that you've been in the part of the channel. You've been in this channel for such a long time that I tend to recognize you as one of the old guard. You know what I mean? Let's go into VIIFS.jl and let's take a look at what we have here. So basically, as we go through, we have a whole bunch of these functions that we can kind of play around with, right? So what I'm going to do initially is just run this code right now to see how long it takes. And right now I have this write image function. So I guess I'm going to pop down here, and I'm going to try the smaller one. And I'm going to take a look at this write image function and see what we're actually doing. So this is just a test. Fractal.png. So we're going to output it to fractal.png. So let's go and quit here. Write and quit here. And let's just run Julia over here. So we're running Julia. And I'm just going to include and see what happens. ifs.jl, ifs.jl. And let's give it a go. Images. So let's do package using packages. PKG, I believe. Yep. And then we're going to do package.add. And let's just do images. Oh man, I've got a feeling. I've got a bad feeling about this. I've got a feeling that today all we're going to end up doing is like fixing up this code so it works with Julia 1. Let's see, James' reference 1 is Gustron 2017 Discord. The fact that it's 2017 Discord actually makes that somehow more correct. Let's see. I really liked his video on that paradox where you can duplicate spheres using the axiom of choice. Oh, you were talking about Vsauce, right? Yeah, honestly, you know who's been super impressive recently? Freaking Dan Schiffman from Coding Train. Holy cow, he's been super impressive. I really have been wanting to, like, just get better after seeing his stuff. Like, he's so cool. I don't know, like, there's so many people that are so cool. Him, obviously, Grant from 3 Blue 1 Brown. There's so many people that I'm just looking at and I think are so really cool. And it's just, I wish I was on their level. And I don't know if anyone else thinks this way about their work either. It's just, you know, like, some days I'll just get up in the morning and I'll be like, man, I need to get better. And I don't get any better that day. Let's see, what do we have here? I really liked his videos on Paradise Choice. I've been in the community since the algorithm archive started. Look at me now, I'm a mod. Yeah, I guess that's true. All right, pre-compiling images, let's see how it goes. You, get better is not a get command. Yeah, one day. Get better. We should add a custom get command. We definitely should for get better. Do you know that the algorithm archive is over a year old? Yeah, I know it is, right? Oh man, I've got nowhere with it. Yeah. And I know why too. It's just I don't have time for it, you know? Get force better. I don't think the force here helps when there is no get better command. You know what I mean? Let me get some water real quick. I'm super tired. The sudo also doesn't help. A no option force. Wait, what? No. What? Force has to be known. Okay. I like the trolly sense of humor we have on this channel. It's my favorite sense of humor. I guess this is not in the sudo's fire. This incident will be reported. Ha. Who is it reported to? What? Actually, wait, Buttercake. Could you simulate that report process and report to me? I'm interested to see what is actually reported in the sudoers file. I've never actually checked. And I don't know if anyone here has checked before. I've got a feeling. But I'm a mod. I've got a feeling that when people say this incident will be reported, no one actually knows what's being reported, you know? Like, does anyone actually check the sudoers file? Like, who? I mean, why is this taking so long to precompile? Come on, Julia. You're supposed to be snappy. You were supposed to be the savior. Where's your speed now? Why is it taking so long to precompile this guy? Okay, we'll just let it do its thing. You know, no rush, no worries. You know, you can take your time. It's not like this is live or anything. Ooh, okay. I just got a comment on, it's reported directly to Linus. Ha. I just got a comment on YouTube and I just can't read it because it's in a language. And then they were complaining that the subtitles were in, like, Spanish or something, and the video is in English. So now I'm worried that maybe there's something wrong with the subtitles. We'll see. Imagine it reports it in temp. Why would he need that? Oh, I mean, I think that I think Linus just enjoys. I think he gets some sort of satisfaction knowing that people don't know how to properly use his operating system. So whenever he gets these notifications from people that, you know, all over the world that basically say that the incident will be reported because they're misusing Linux, I think he gets, you know, I don't know. I would be happy to know that at least people are using. No. No, this isn't going to be one of those days, is it? A10-2 not defined. Oh, but maybe this is... Okay, so we can't use images. So this is something wrong with this guy. So let's go into A10-2. Yeah, okay, this is the problem. It's because A10-2 is different now? I think I ran into this problem before. I think I did. A10-2 works slightly differently. Or else there isn't an A10-2? Something like this. Let me take a look here. A10-2, Julia. And let me see. I think it's changed slightly. Let's see. May 25th, 5 comments. Let's see. We could at least allow A10. Let's see. Well, let's see what happens if we just do A10-2. We remove the 2 here. All right? It's going to be one of those days. Oh my gosh. I was hoping today would be the day that we create fractal Christmas trees, but instead today's going to be the day that we update our Julia code to work with Julia 1. And we'll get to the fractal Christmas trees when we get to the fractal Christmas trees. Did you see this color animator? Oh, I did not. Thank you so much. I was going to do that coming up. But now that that's in there, yeah, let's just go ahead and add that in there. Thank you so much. That was actually a lot quicker than I was expecting. So yeah, that solves one of our issues. Is this according to the GDPR? Wait, is that according to GDPR? Actually, no, I don't know what we're talking about anymore. No method matching array RGB. No, oh no. Oh no. Oh, this is gonna be one of those days, isn't it? Oh gosh, darn it. Where actually is this guy? Load error. No method matching array at boot.jl, boot.jl, sys image, write image. Okay, so we're looking at write image 111. Okay, so here we are, array of RGB, NOF82, size P1, size P2, and the issue here is that there's no method matching RGB normed, U8 int. Jeez, how are we gonna create colored images now? I'm so confused. Okay, so I guess what we're gonna have to do, by one of those days, I mean, make it RGBA squared. Oh yeah, this is a good idea. Yeah, thanks. Is that actually what I'm supposed to do? I don't know. It's one of those days where I have no idea what I'm doing. That's what one of those days are. Because like it was one of those days where I was going to come in, we're going to create a fractal flame Christmas tree. It's going to be great. And now it's a day where all we're doing is updating Julia. Which I guess is what happens when you haven't looked at Julia code in a while. It looks like every other day, Kappa. Yeah, it does. And that's the sad truth of the Simuleos channel. It seems like every day looks like every other day, and we're doing nothing, actually. So what do you guys think? Should we do... I'm actually thinking that maybe we should do a day where we do the Christmas tree drawing on the GPU. Maybe that's something that we should try. I don't know how well... sorry for the yawn. I don't know how well the I don't know how well the IFS systems will parallelize. I've got a feeling they won't do very well because they have random input, but it'd be interesting to try nonetheless. Okay, so let's just look at images, and let's see what we got here. That's not what I wanted. Not what I wanted at all. Thanks, Google. Search. Okay. No, it has a JL. Okay. I guess images.jl Julia? Nah, that's what I'm looking for. Check 1 minute physics on YouTube. It's some short explanation of RGB squared. Oh, yeah. Fair. I know what you're talking about. Image processing library, full documentation, Julia images. Nice. What I'm looking for is how to write to file. Arrays, numbers, and colors. Array of float 64. I want colors. Gray. 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 Give me some colors. RGB float 32. Let's see what we got here. I have RGB, but I want RGB float 32. Is it 32? Okay, whatever. Wait, is that lowercase f? No, it's capital F. Alright, let's see what happens when we run that. Let's go! Yeah! It's gonna fail! RGB float 32, no method matching array, RGB float 32, 2 int. Alright, so your problem isn't... Okay. So what is your problem? Is your problem the fact that we're using... Nope, I have no idea what your problem is. No idea what your problem is whatsoever. Let's go ahead and... The issue, I think, is the way that we're calling this array command. I think it's how we're calling this array command. No, I think he's talking about the RGB. I think when he talks about the red, green, blue color, I think it's fine. Yeah, I think I know which video this is. Yep, that's the one I was expecting. I'm not gonna watch it on stream, but I mean I have it queued up. Okay, so I think there's something wrong with this function call itself. Let me try something real quick. So array, ooh, come on, dog. We're just gonna say array of float 64. And we're just gonna say, let's say 2. Yeah, okay. So this is my problem. So if we say A is gonna be equal to array of float 64, 2, that's the thing that has been changed. So how do we get this to work? Array of 2? Actually, how do we get this to work? I remember there being something weird. So array Julia. I took it apart? Are you supposed to take it apart? I assume it's like one of those blacksmith puzzles. Oh no. Control F array doesn't help me. Oh my word. Yep, I know that's a 5-element array. I get that. I get that. Array float 64 1. So what I'm wanting is array. Let's see. I want array float 64 1. Nope. No, you're failing me, Julia documentation. You are totally failing me. I need an undef. That's what I need. Alright, let's do it. Actually, what can I do? This? I don't know what I'm doing anymore. Let's just do that. Look at that, it's running. Yeah. Come on. Come on. Yeah, error encountered, but different error. All right. This is perfect. Look at that error. There's no way I'm gonna be able to tell what just happened. Yep. Alright, let's just go ahead and cancel this guy. We're gonna have to add image magic anyway, so let's just do package.add, and we're just gonna add image magic. Alright. Since we're gonna have to do it anyway, might as well add it now. Oh my word. It is one of those days. N-O-F-8. Let's go. What do we have here? Took it apart. I have not put it back together. The man, he's done it. I have not done anything. It's so broken. Buttercake is so smart. Oh, you're talking about Buttercake. Of course you're talking about Buttercake. Good luck putting it back together. Yeah, about that. Hey, Folster, how are you? Lamer Yo, just read the log. Forehead, just read the log. Wait, what the F is that up there? Cheer 2? Thanks for the cheers. I guess you finally realized that I think Folster is something was ahead. Since he's using... Oh, hello there. Let's... Yeah, dagnabbit. Write that. Go over here. Let's do using image magic. Bam. Let's go. Pre-compiling image magic. This is what I want to do with my life. I mean, like, don't get me wrong. If If I had to choose between precompiling images and precompiling image magic, it'd be a tough choice, but I think I would choose image magic. It's just a little faster. Oh, it's TS Joss. Yeah, sorry about that. I didn't remember who it was. I should probably remember stuff like that. Couldn't be recognized by file IO. Okay, file IO.file, data format. Well, how do you not know what a PNG image is? What? What do you mean you don't know what a PNG image is? All right. Save? Of course it's not a save command. Freaking, yeah, okay. Let's see. How do we save? All right. Julia, images, saving, file. Save an image file. All right. December 20th, 2015. I don't think this is valid anymore. I don't think this is valid at all anymore. I think I was using the save before, and I don't think save exists anymore. So how do we, let's see, Control F PNG? Nope. Let's pop up here. This is a full documentation, isn't it? How do you have a full documentation? Oh, this is arrays and tuples. Okay. Let's see, arrays numbers. What I'm looking for is here, save. Okay, let's do PNG. Okay. All right. Size. Image. Image D. And the question is, how do you write this to an image? Before it was just a save command, but now what is it? Come on, Julia. Give me something. Okay. Hey, C252, how are you, man? We're not using FFmpeg. No, we're not using FFmpeg. We're using Julia at this point. It's a mod of Buttercake. Buttercake is a mod, but Buttercake isn't. Do you want me to mod Buttercake? I can mod... Oh, no, he declined being a mod. I had forgotten. Number one in Python for tree traversal. I missed a lot, didn't I? I've got the formula. If you decide to do it, I'm there. Oh, this one's... Oh. Let's see. Gathos GitHub.com algorithm archive is Gath GP. Oh, yeah, nice. Thank you so much for that, by the way. Stimulus, I started streaming. Oh, nice. I'm quite interested in looking at your stream, so I will actually probably follow you right now. Wait, no. Am I already following you? One second. What am I doing with my life? Fulter. Add friend. No, I just want to check out your channel real quick. Am I following? I'm not following. I'm now following, but I will not get notifications. I'm sorry. Those notifications are annoying. I'll watch you when I'm also online. Just got glasses and I can read the code now. Oh man, dude, that is a big step up from what you were doing last time, where you were not reading the code without glasses. I mean, it's pretty good. Look at the code. Okay, so let's see if we can figure out what the deal is here. So the save function is not working, right? This is clearly a problem, but I don't know how to fix the problem. So this file I to a file. Fractal.png could not be recognized. Let me see if it can recognize a JPEG. All right. All right, this is crazy. It's not going to be able to find a JPEG. It's not going to be able to find one at all. Let's see. Let's see, Fulter played around with some super great music on the piano. No! No, it didn't just work. Oh, my word. It can recognize JPG images, but not PNG. Oh, no way. Mirage Fractal .jpg. It does, though. It recognized JPG. Oh, man. I don't know what to say to that. I don't know what to say to that at all. I wanted a PNG. What? What? Come on. No. No way. All right. Okay. We can do everything in JPG. Are we making the Christmas tree? Yeah, we're going to try to make the Christmas tree. We're going to see. Yeah, I wanted PNG because it's lossless. Yeah, that was kind of why I wanted PNG. This is true. PNG's better though, Julia. Yeah, I'm going to... Let me see if in the Julia documentation, what do we have here? Log da 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 da. JPG? Nope. It doesn't tell me how to save these images. Have you tried? What other lossless formats are there? Let's see. Lossless. BMP maybe? I don't know. GIF, PNG. I know I'm most familiar with PNG. Vector formats, SVG, TIFF, GIF, BMP. It is super important for fractals. Let's see, include ifs.jl. Oh, I've got a feeling. No, it doesn't. It only recognizes JPG, it seems. JPG. All right. So we know JPG works. Now the question is why? Think TIFF? Yeah, let's try TIFF. Why did you put that in all caps? Did I miss you before? TIFF. Am I allowed to do .tiff? Oh, my bad. Come on, dog. Let's go. Okay, TIFF worked. Oh, oops. Let me open up another terminal here that's in the appropriate directory. I don't know why TIFF worked. Let's just take a look at TIFF then. All right, I don't mind. CD and project Simuleos, and let's do fractal dot something, and let's just do Mirage fractal dot TIFF. All right, yeah, it works. Fine, we'll do .tiff. All right, we're just doing .tiff from now on. I'm not gonna worry about this. The code seems to run, which is more than I expected. You know, this is good. So let's go ahead and write quit, and let's just do git. Let's clear the terminal because it's messy. Now let's do git add fractal.jl. Oh, actually, this is going to be ifs.jl. And we're going to do git commit -m updating ifs.jl to Julia 1. Git push. Git push. Origin master. All right, nice. Don't ask me why TIFF worked, but it worked. I'm okay with it. Let's go. Oh, well, okay. Yeah, this is fine. Try BMP. I tried BMP. BMP didn't work. TIFF can contain both lossy and lossless images. All right, let me just see if we can figure out the save command. There's something clearly going wrong with the save command. So save an image. What do we have? Save. Is there something I'm missing with the image command? Let me take a look here. No. What am I looking for? ATAN2 doesn't exist. We're already past that error. Demos, demonstrations, color separation, and SVD, summary and function. Summary and function reference. Let's just go there. Loading and saving. Load, save. They're using the save command, but the save command couldn't. They're literally loading my image.png and saving .jpg. Okay. Ellis here. We have all these PNGs. Let me try something in the Julia terminal. Let me load an image. We're just gonna load fractal.png. Okay? And we're just gonna see if this works. Yeah, okay, so it can't recognize the PNG file. Why? Wait, maybe capitalization is important? Wait, why would capitalization be important here? So let's say Julia not recognizing PNG files. Julia save not recognizing PNG files. And let's see what we got here. Nope. No, I wanted font set for plot using PDF. iJulia, IPython. Nope. Come on. You know what I'm looking for. I just Googled for it. Give me some Julia. This is Photoshop. Julia Lang? Gadfly SVGs render without color. Fonts after plot. Nope. Come on. Export as PNG does not recognize. Nope. None of these are what I wanted. Export image using images in Julia. Alright, let's take a look. PNG. I'm right and I'm read are both have been deprecated since version. Let's see, save. I'm right, grade convert. Okay. They are also saying do you save and load? Just fork Julia and add PNG support? I could. But I feel like that's probably a little bit too much work for this. Wait, maybe capitalization is important? What do you mean capitalization is important? Like, what do you think, what type of capitalization should we be looking for here? Because honestly, I don't know of any capitalized PNG. I've never heard PNG shout at people before. None of these are the errors I'm looking for, so let me see if I can just, couldn't be recognized by file IO. Let me see if I can just find PNG. PNG. Okay. Save code path should never be checked by magic bytes. Fix step warns. Let's see. We wanted to contribute to FOSS anyway. Ha! That is definitely true. Couldn't recognize the image format file background dot. Oh, this looks like it's Python. I specifically wanted Julia. Let's see. Julia Ling, load function images doesn't recognize file format. This seems like we're getting somewhere. According to the statement, file IO data, the file extension is wrong. .bpm instead of bmp. No. No, see, that doesn't work. That doesn't work at all. All right. Load function issue 440. Let's see. All right, save RGB.png color view. This is not gonna work. Hope you're having a good day. I'm having a great day, Duck of Doom. Thanks so much for asking. I hope you're also having a great day. So if I go over here and I run this, it's just, how did that work? That means that the, take a look at the type of this color view, RGB function here. This is float 64. Is it because we're using a different, let's try this. Let's try ifs.jl and let's just run down to, write image. And let's try changing this to a PNG. And let me try adding an NOF8 here, because apparently I don't have one. And now let's try, where are you, dog? Include ifs.jl. I've got a feeling this isn't going to work, but maybe if I change this to, yeah, that didn't work, but let's try changing this to float 64. I'm changing this to float 64. Yeah, float, yeah, okay. That's my bad. Time for that awkward situation where you look for a problem online and you find Stack Overflow from 1 year ago, where OP is yourself and there are no answers. Yeah, been there. Hey, Greek Jesus, you're right. Let's see. I don't understand how that save command worked. Because I can't load anything. See, if I try to load that function, so let's do load, and let's try load rgb.png. How is this working? Because if I load fractal.png, I don't get it. I don't understand. I don't understand at all. If I load rgb.png, it works. But if I load fractal.png, let me just pop over here to the second terminal. Let's do a quick mirage of fractal.png. And let's see what we got. So that's clearly not a fractal.png. Maybe fractal.png doesn't exist. Maybe that was my problem. Let's try an actual PNG image that does exist. Check.png. Okay, so let's do check. Okay, check.png works. So now the question is, why am I not able to save? Am I not able to save? No, I have no idea. All right, we figured out one problem. I'm sorry, I'm an idiot. That's problem number one. We didn't have the file before. All right. Problem number two is why is it not saving? If the file is there. Try file fractal. Maybe. What? Okay, so I guess there was already a file.png, and the file was empty. So I removed the file, and now I did call it Flame, didn't I? I didn't misspell the title of the Fractal Christmas tree. Yeah, okay, fine. I just said Fractal. I didn't even say Fractal Flame. Fractal Flame Fluke. I'm sorry. Okay, fine, whatever. Let me go ahead and add this too. So git status add ifs.jl git commit -m adding PNG support. Okay. It's one of those days. Alright, regardless, we have something that's kind of sort of almost working. Mirage, I think, fractal.png. Yeah, okay. Here's our little heart thing that we were drawing before. It's a bit weird that it's so close when before it was so far away. I gotta admit, that is a bit weird to me. So let me see if there's something wrong with the scaling now. Fractal.tiff. Yeah, okay. So let's see if there's something different with the scaling real quick. So let's go into ifs.jl, pop down here, and let me see what we have here. So it looks like we have, there is something different with the scaling. So let's change this to 4 and 4. Actually, let me just look for flame. Flame there, yep, flame there. Sierpinski flame, yep, Sierpinski, yep, I gotcha. Come on. There, nope, there we go. So it's gonna be scale Y and then gamma, but what is gamma? Gamma is, okay, so gamma is some sort of gamma value. Okay, I gotcha. So let's change this to 4, 4, and 1. And 4 and 4. Okay, so what we're doing here, and 1,000 by 1,000 pixels, yeah, okay. So let's go ahead and do, actually let's lower the pixel count. So let's do 500 by 500. Just because I like lowering pixel count sometimes. Okay, so now we're gonna do, where am I? Julia over here. Include ifs.jl. And now we're gonna pop over here, and we're gonna do mirage fractal.png. Okay, so here's our fractal. I understand this is a bit lower resolution than it was before. Whatever, we'll keep it 1,000 by 1,000. Who am I kidding? You know, we're going all out for this community. 1,000 by 1,000. Let's go. All right, move over here. Let's do Julia ifs.jl. Let's go. Flame, fluke, flint, flunk. What? Is that a word? Flank? It is now. It seems so. Let's see. Julia images, GitHub function reference. Thank you so much for that, Lamer Yo. Yeah, I know. That's what we had. I don't know what the deal was. SP5 letters. No. 1,000 by 1,000. Flies, flips. 5-letter word starting with FL. Life. My fractals are usually 5,000 by 5,000. I understand. We'll do higher resolution fractals in a bit. For now, we're just trying to get these flames started. The flames of whatever hearts are. I guess I don't want to say flames of love. That's really weird. Ugh. Okay, so let's change the fractal up then. So we have the ifs.jl that has basically some sort of flame in there. And let me go ahead and take a look at this flame function and see what we have. So function flame, here we are there. We have resolution X, resolution Y, that seems fine. We have the pixels, everything's being defined. Here's a Barnsley fern. Barnsley Flame, I'm sorry, Serpensky Flame, blending the colors. But my question is, we have the Serpensky Flame, the sinusoidal, linear. Ah, I see. I see exactly what we're doing now. So right now we're just using the sinusoidal, linear, and swirl, and we're just basically choosing between these guys at random. But it looks like we could basically change these guys. So let's go ahead G down here, and let me try changing the flame up, and we should get a radically different image. So I'm going to go ahead and right and quit and go ahead and copy this. So we're going to cp ifs.jl into heart.jl. We'll say heartflame.jl, and now we're going to go into the ifs one more time, and we're going to go from there. I'm so sorry. I'm so sorry. I don't know anymore. What do we do? Fractals usually. Okay, so let's see. We have linear, heart, sinusoidal, heart. Yeah, so we have the final point heart. So basically, the idea here is we do some sort of mixture between all of these different, I don't know how to put them, but all of these different flames. So if we change this one to linear, and we give this a guy, I guess a 0.5 in here. We pop down here, and we're going to run the last Julia ifs.jl. We should get a radically different fractal.png image, which should be here. And we do. Look at that. I don't know what we're looking at, or why it's so small, but we have stuff. That's pretty cool. Okay, so now the question is, how exactly do we get this to work? So let's go ahead and change this to green. So R, let's see, G, B. Let's try running that one more time. I think we're just going to have to mess around with this a lot. Folster wins. Flesh. Oh, my word. Yep, Folster wins. Alright, so here we got the green. We are starting to build a Christmas tree in there, I think. You know, this swirl thing doesn't make any sense. So what I'm going to try then is, I'm going to try changing the swirl guy. So I'm going to remove the swirl from our IFS function entirely. And I'm going to replace it with another linear. So let's go and yank here and paste it down here. And let's try this, include ifs.jl. Pop over here, mirage fractal.png. Perfect, look at that. Oh yeah, that is not what I wanted. I guess maybe we do need the swirl, but maybe we need it to be less ostentatious. So let's see, sinusoidal. Let's go ahead and remove this guy. Yeah, I don't know what I'm doing anymore. I just don't know. We're just gonna have to mess around with stuff. I want a flash flood of flies. Oh no. No, you do not want that. Did I just generate a single point? Oh, what is happening? Let's add the sinusoidal back. Merge fractal.png. It's just, I don't know why I have a second Julia terminal up. I can just run Julia ifs.jl. Okay. I know we have to generate a lot more points to generate this in a very pretty way. What I think I'm going to try to do is I'm going to try to draw a cone. You know, that kind of goes up here. A cone Christmas tree. And then I want to draw like a star at the top. Now the thing is, I think, let's go ahead and lower the bounds a bit. So let's change this to 2x2 again. Let's take a look closer at what we're looking at. You know what I'm saying. Include ifs.jl. This will take a little bit longer to run. I'm generating 10 times more points. And then once it's done, we'll take a look at that. Looks like a green snow. Yeah, we're getting there. Green snow it's still snow. We're getting there. You know, Christmas, guys. This is not going to turn out well, is it? I have no idea how to do any of this. You could have the star be a Coke snowflake. Oh yeah, maybe. Mirage fractal.png. Okay, so here's what our fractal looks like so far. Look, don't get me wrong, we got the green part of the Christmas tree, but we have literally nothing else. It just looks like garbage. I mean, don't get me wrong, like, it's kind of cool, but like, I mean, okay, it's really cool, but it's not like what we're looking for, you know? It's nice. If I generate more points, basically the reason, like, we don't have the appropriate blurring in yet, so I need to generate a lot more points to make this look pretty. But this is not a Christmas tree. No matter how we shape it, This doesn't look like, it looks like an Illuminati tree. Is that a thing? Illuminati cone? I don't know what we're talking about anymore. Like, it's not quite what I want. Can you put that in the Discord? I can, but I want to generate like a better one at this point. Well, okay, how about we generate a better one? It won't take that long. Let's just go ahead and generate a slightly better one than that, and then I'll put it in the Discord. Right, that, go over here, we'll run include ifs.jl, and then we'll try this Christmas tree guy. So while this is running, let's go ahead and take a look at what we actually have to pull from. And by that, I mean, I'm gonna go to the Fractal Flame paper that we have. And note that with the Fractal Flame paper, we're actually missing a few things. So what we're missing is basically the filtering, the motion blur, and the directional motion blur, okay? But I don't think we need the motion blur or the directional motion blur. I think we're okay. I think we're okay with that. But let me take a look at what we have here. So what they're saying, maybe we should use the motion blur. You know what? Screw it. Screw it. Let's go ahead and implement the Fractal Flame algorithm all the way, because we're missing some stuff, you know? So let's go ahead and try to get a fractal that's kind of sort of working the way we want it to work. And then we'll add in the motion blur and we'll add everything else in, because this actually looks quite cool. So here's a low resolution image. So low resolution, low quality, zoomed image rendered without density estimation. B is with density estimation, and C is high quality rendered at high resolution with density estimation. That looks pretty darn sweet. I mean, look at that. Even zooming in, it looks pretty cool. That's what we need to do with our lives. Look at that. It's a crop circle of Christmas tree. Christmas tree without motion blur. I've got a feeling. Yeah, okay. I'm interested. I'm now very interested. So what do we have here? So that is with density estimation, filtering. So what we're missing, I think, so we have the gamma factor, but we're missing everything past the gamma factor. So I think we can spend this week. I think we can spend this week doing Christmas tree stuff. I think we can spend this week just implementing Fractal Flame methods and getting this working, because I'm very interested in this. I think it's really cool. So let's take a look at the appendix here. So here's all the different variations that we have. Linear, sinusoidal, let's see, spherical, swirl, which is what I do have a swirl in there, horseshoe, polar, handkerchief, heart, disc, spiral, hyperbolic, diamond. We might be able to use a diamond for something. Let's see. Variation, Julia. That looks so cool. Doesn't that look cool though? Okay, anyway. Bent. Ooh, we might be able to find a way to use the bent. Anyway. Waves, fisheye, popcorn, exponential, power, cosine, rings, fan. Maybe. Let's see, blob, PDJ, let's see, fan 2. Again, a maybe. Rings 2. I'm trying to find ones that look Christmas-like, Christmas tree-like, you know what I mean? Bubble, cylinder, perspective. Noise. Okay. Julia N. Let's see. Blur. Yeah, it's not going to do anything. Gaussian. Radial blur. Pi. This is something we could use. I'm almost positive. Look at that conical shape. Ooh, that looks like a little angel. Yeah, okay, I like that. Curl, rectangles, arch, tangent, square. Raise. This one looks useful too. Ah, man, that looks just like a Christmas tree. Blade, secant, and twin trail. Yeah, okay, there has to be ways to get this to work. There has to be. Rock Hardy 54. Usually we'll work on this, the algorithm archive. Yeah, so basically what we're doing right now is we are implementing a new algorithm. Well, an algorithm we've implemented before, known as the Fractal Flame method. So this is a way of taking fractals and creating a unique visual image with said fractals. What we're trying to do is we're trying to create a Christmas fractal tree, exactly like C252 says. And we're hoping that we can get this out by the end of this week so we can create a video on it in Laos OS, the YouTube channel that corresponds with this. And we'll see how it goes. Okay, so it looks like this is done. So let's take a look at the image, miragefractal.png. Yeah, okay, so here's what we got so far. That looks nothing like a Christmas tree. It's green. I mean, I'll give you that. It is green. but it is not a Christmas tree. I need to generate a lot more points and stuff, but yeah, if you guys want, I can post this on the Discord. So let me just go ahead and go on the Discord real quick, and let's go. I guess I'll put it in here, stream note. We'll put it in off topic. Why not? So let's do fractal.png, open that guy, and let's upload that. Okay. So now we're back to where it was before. I made a fractal tree and put annoying lights on it. What language are you using? This looks interesting, to be honest. I'm currently using the Julia language, although we use a whole bunch of different languages for the algorithm archive. If you go to the algorithmarchive.org, let's just go there real quick. It basically has all the different languages you could hope for. Like, for example, just go to bubble sort. It's got freaking x86 to 64 assembly, TI-83 basic. It's got everything. Well, most things, you know, even emoji code, which is, by the way, pretty fast when compared to MATLAB. Julia is a language that I primarily write in nowadays, just because I used to write in C++, but most people got pretty upset. Yeah, here's the Barnsley fern. Oh, you know what? Screw it. That guy looks super Christmassy. Let's go. Let's try something real quick. I know what I'm going to do. I know exactly what I'm going to do. Let me just try something. Because maybe this is a lot easier than we're trying to make it out to be. So the final point here is linear, but let me just go ahead and yank this, paste it here, and change this to Barnsley. Because I know we have a Barnsley flame. So let me see what happens if we just change this to Barnsley. How do you say Barnsley? And let's just change it to point, and then... Wait a minute, how does my Barnsley flame work? It seems to work differently than everyone else's. Function Serpensky. Function Barnsley fern. Close F. But I want Barnsley flame. Chosen function. What is this? What am I looking at? Okay, let's just try... I have no idea what I'm looking at, honestly. I have no idea. Let's just try. I'm just gonna try to call something at this point. Let's go and do D here, and let's just say 4. I don't know. And let's also lower the resolution here. By, let's just say an order of magnitude. 2 orders of magnitude. Julia include IFS. Julia is a language made by MIT people for scientific computing. Barnsley's not defined. Of course it's not, because I'm an idiot. Barnsley flame. This is true. It's meant to be a replacement for Fortran and MATLAB, I believe. Yeah, basically that. Let's pop over here and let's do miragefractal.png. Yeah, look at that. Screw that. Okay, what then is my problem? I've got a feeling I know my problem. I've got a feeling what I need to do... Why am I doing it this way? I've got a feeling what I need to do is take this guy here and put it down here. All right, so let's see. Let's try some things here. All right, let's give this guy a go. All right. Mirage Fractal.png. Yo! That's not what I wanted at all. Yep. This is definitely a Christmas tree. You can tell from all the Christmas. At least it looks better than MATLAB. Yeah, so it's much faster than MATLAB too. It's about 100 times faster than MATLAB in most cases. It's roughly the speed of C. And it's much easier to write. Yeah, this is clearly not a Christmas tree. Whatever I was trying to do didn't work. So let's try removing all this crap that I just put down, and let's try this again. So let's just DDDDDD. If anyone plays Smash Brothers, you know that DDD is a character, but that's not what I'm talking about here. So I'm just gonna DD here. I'm going to comment all of this out for now, and I'm just going to see if we can get a general fern going. And then we'll kind of go from there. Include ifs.jl. Final point not defined. Yep, that is because I think I just want to call these all final point. Let's go. Come on. And I want to do Mirage Fractal.png. Okay, so here's our Barnsley Fern. It is way bigger than I have allowed. So let's go ahead and increase the size of G down here. Let's increase the size of this box to be 4x4. So we're going to do Julia ifs.jl, and then once that runs, we're going to run Mirage Fractal.png. Yeah, so our fern is starting to be generated down here. It's just a very large fern. I didn't realize how large it was. So that would explain why we're having so much trouble with it. His down move is top tier. I mean Waluigi, his down move is top tier. I've been playing a bit of Smash. I basically only play Wii Fit Trainer. I really like Wii Fit Trainer. They're really good. I know, actually, honestly, I don't think that's true. I genuinely think Wii Fit Trainer is one of the worst characters in the game. If anyone is following Smash, I genuinely 100% believe that's true. However, I genuinely like playing with them, so I don't really care that much. Okay, so let's see, what do we have here? Stravinsky, sinusoidal. Is there a way to make this fern smaller? Let's go up to the Barnsley Flame. Barnsley Flame. Is that... Come on. Can't spell anything. Cannot spell anything. Where do we have? Barnsley Flame in here. What I want to try to do is make this a smaller flame. So let's take this 0.12. What are we doing here? I have no idea. Oh, I see. I see. Okay. I know what we're doing here. We are coloring each individual. So the first two elements of every point is its XY location, and the next three elements of every point is its RGB color. Okay, I got it. So this means that what we're doing is we are making this fern a certain size. So let's see how big this fern is actually. So let's just G here, and I'm going to increase this to 8x8. Let's say 8 by 8. And we're just going to run this guy real quick. Include ifs.jl. And then we will give that guy a go. And I believe we should have the whole fern here. No. Holy cow. How big is this fern? Jeez. Let's go to 16 by 16. I know the fern is upside down. I'm sorry about that. ifs.jl. I'm not exactly sure why the fern is upside down. We're just going to play around with it, see if we can get it to be right side up. Honestly, that's what a lot of the stream is going to be, just playing around with things. Hello, fern. Why are you still... Okay, let's try this again. Let's try 32 by 32. Okay. So there's the entire fern. We finally got it all in one image, which is kind of nice. Granted, because of the size of this, it's kind of low resolution, but we do have the whole fern here, and we do see kind of what we're expecting, right? Like, it's blue, green, and then it kind of fades into this reddish color, and that's okay. What do you mean, we always hang my Christmas tree from the ceiling where I'm from? I'm sure you do. I'm sure you do. Sidazu, Fractal's cool. Yeah, that's kind of what we're working on. So here's our Barnsley fern. Admittedly, this looks more Christmas tree-like than any other Christmas tree we have so far. So I'm okay with using something like the Barnsley fern to work with here. The problem is the Barnsley fern is gigantic when compared to all the other fractals that we have here. So let's go up here to the top, and what I'm going to try to do, actually, let's go and do flame. Yeah, here it is. What I'm going to try to do, I'm going to try doing what I did just a second ago. So let's go ahead and DD here, and let's DD there. Let's go ahead and comment this guy out over here. And let me see if this final transformation here will, hello. I'm going to DD there. And let's just go ahead and D70. Ah, dang it. It was 9. So let's go ahead and give this guy a go. Include ifs.jl. And I'm just going to see what it looks like. You know, we're getting closer in that Mirage Fractal.png. Ho, ho. Oh, my word. That is not what I was expecting. How do you get the color variation? Why is the top one's different than the color from the rest? So what we're doing here is, how do I put this? So every single one of these transformations, sinusoidal has a color associated with it. It is blue, RGB. Linear has another color, it's RGB, so it's red. Swirl has another color associated with it, and it's white. So basically all of these different variations has a different color associated with it. And what we're doing is we're mixing all of these colors together in the end. I want to get a closer look at that fractal. Admittedly, not the fractal I was looking for, but I do want to take a look at it. So let's do 16 here, 16 there. Write this, go over here. Let's try juliaifs.jl, and let's give that guy a go. Recently got an assignment to multi-thread a Mandelbrot set generator. Had a pretty cool aha moment. Mirage Fractal.png. Again, not what I'm looking for here, but it is quite interesting to see what's happening. I'm going to generate a slightly high resolution image here, so let's go to 8x8. Actually, let me see, can we do 8x8? Let's do 6x6. Let's do 10x10. Include IFS. I also meant the same with the Barnsley Fern. So with the Barnsley Fern, each transformation, I'll take a look at it one more time. Yeah, okay, that's most of the fractal there. So with the Barnsley Fern, the way that we had it was Barnsley Flame. Each one of these transformations on the Barnsley Fern. So the Barnsley Fern itself has like 4 different transformations associated with it. One for the stem, one for like the primary leaves, one for like different things. I don't remember what they all stand for. But each of these transformations have a color associated with them. So white would be for the primary stem. Then we have red for like going left, green for going right. I don't know what it is, but they all have different different things. Multiply y coordinates by -1. I could. Yeah, I definitely could. I made this L system. Yeah, let me take a look. How to turn over the image. It grows down instead of up. Right now, oh, that's not bad. That's much better than my Christmas tree. Whatever the heck I'm doing, it's just all broken. Everything I'm doing is just broken. But that's fine. You know, everything breaks at some point. So I'm going to pop down here. I'm going to increase the number of points that we're taking by an order of magnitude here. Let's just go ahead and try. Come on. This. Include ifs.jl. Give it a second to run. I can find a way to flip the fern. I'm not too worried about flipping the fern. What I'm worried about right now is getting the right shape. Which I'm clearly not, because right now I just have this giant swirl thing that doesn't look anything like a Christmas tree. I'm thinking what we want to do is some sort of small-scale transformations on top of the Barnsley Fern, because right now the fern looks the most Christmas tree-like of any of the trees that we've generated so far, which says something. It says that maybe we're barking up the wrong tree. So what I think we want to do is figure out which part of the Barnsley Fern transformation does the leaf part, and we want to transform that part of the fern itself. Does that make sense? So here's a closer look at the fractal that we were generating. You can tell that... Okay, so let's talk about what we're looking at here. If you remember from the Barnsley Fern image that we had before, we had basically a blue part, a green part, a white part, and all these different parts, right? So here we're seeing each of these parts swirl around in a different way, right? So I think if we remove the swirl... Let's try removing the swirl and putting in a linear. So let's see, what do we have here? Swirl. So let's, I don't know what this will do. I'm sorry, I didn't mean to hit the microphone. I apologize. Let's yank and paste this down here. Maybe if we combine the Sierpinski triangle and the Barnsley Fern, we get something interesting? I feel like that's not going to be too interesting. I'm sorry about booping the mic. I'm so sorry. I can't believe I just used your word boop. Okay, let's pop down here and let's change this here. Mirage Fractal.png. Okay, hello, Fractal. What are we looking at here? There's the stem. There's one right leaf. There's a left relief. And there's everything else. Yeah, that didn't work. All right, let's try this again. Include IFS. So you're combining fractals to generate Christmas tree. That's basically what we're doing. Yeah, that's what we're trying anyway. Fractal.png. See, this also looks nothing like a Christmas tree. Like that looks more like a Christmas tree than whatever this is. Ah. Hello, there you are. See, this is the Barnsley fern, right? You can see the fern. There's the stem. There's one leaf. There's another leaf. And here's the rest of the fern itself, you know? You can kind of see where it's coming from. L system for Julia. I think you... Yeah. Yeah. Yeah, these are way closer to what we want. We can do an L system. I wanted to do the fractal flame. I just like the fractal flame. But again, this system, I mean, look at this. These look like Christmas trees. I mean, more than whatever we're doing. In that ours doesn't look at all like a Christmas tree, you know? Except for the Barnsley fern, which is not meant to be a Christmas tree. Now, there could be a way to... See, the thing is, I don't know how to decorate the tree either. Like, what are we going to do? Like, we can... The thing is, with, like, an ASCII tree, at the very least with an ASCII tree, I could, like, put different ornaments on it and do some sort of cool animation. Okay, well, we'll see what we can do. So it looks like the linear transformation isn't quite what I wanted. The swirl, let's see, the Sierpinski flame. Dragon curve Christmas tree would be great. Yeah, I don't know how to do that, though. Like, don't get me wrong, like, I can kind of see it, but I just don't know how to do it appropriately, you know? Like, I don't know. Point. Yes, this is what I want. So what I'm doing now is I'm combining the Sierpinski triangle and the Barnsley fern, which are the two most... Why not make an ASCII one too? It's because it's too much work. Do you know how much... The ASCII one's going to take a lot of work. Oh, what am I looking at here? Let me remove the final transformation down here. Come on. That's the one I wanted. Thanks. So let me remove this transformation here. And what we should see, unless I've done something completely wrong, is we should just see the Sierpinski triangle. Hello. Come on. Include ifs.jl. Yeah, the ASCII one would take a lot of work. Fractal.png. Yeah, so here's our triangle. That's exactly what we expected. Granted, it's a little bit smaller than we expected, but it's there. That's the triangle that we're looking for. Okay, so we have our triangle. Oh, this was something weird with my triangle and the triangle that Foldster made like months ago. Mine was just like blue, pink, you know, yellow or something like that. But his was like way varying in different colors. So there was that guy. And then when we add in the fern as a final transformation, it changes drastically. Yeah, this is nothing. Like, I don't even know what I'm looking at here. Let's try G down here. Let's just try decreasing size here to maybe 5 by 5. Actually, let me take a look again. Let's try 5. Yeah, but I am average. That's the thing. Like, I swear I am. Or something like that. I don't remember. I don't remember what the problem is. Include ifs.jl. And let's go to miragefractal.png. Yeah, there's no way we can actually... Yeah. Okay, so let's zoom in here. Yeah, there's no way we can turn this into a Christmas tree. That's not going to be a Christmas tree, like, at all. There's nothing we can do there. Yeah, the fern was the most Christmas tree-like thing that we saw. Just by far. So let's go ahead to, let's take a look at the fern on Wikipedia real quick. So let's go to Barnsley fern. And let's see what we have here. So here's the Barnsley fern. So each part in the fern represents a different part. So we have the stem, the successive smaller leaflets, largest left-hand leaflet, and the largest right-hand leaflet. So basically the idea is that each of these guys deals with a different part of the fern, right? So that's why we have different colors in our fern that we saw. We have like, basically, let's show it one more time. See you, Trash Talk, thank you so much for coming in. So let's pop in here. And let's just do the Barnsley fern in here without anything else. So we're just going to grab this guy, do that. Comment this guy out up here. And let's run Julia, ifs.jl. And you'll see that when we generate this plot, we have the Barnsley fern with basically different colors on the leaves. So let's do more here. Yeah, I'm sorry about that. We start at 0, 0. So the first one's blue, then we have green. We have a white stem, and then basically everything else is red if you keep going down. And that corresponds to what we see over here. Stem, successively smaller leaflets, everything in there. Then we have the left-hand leaflet and the right-hand leaflet, right? So we have the left and right-hand leaflets. We could probably perform some sort of transformation on those left and right-hand leaflets to kind of like smooth it out a bit. Or maybe there's a way to smooth everything out to begin with. So let me try something else then. Let me try doing the Barnsley fern first, actually, and then performing a final linear transformation on that fern. So let's go up here and let's just try it out. So here we're gonna have the Barnsley fern as we had before. And then we're just gonna perform a final linear transformation on that fern. All right, let's go ahead and change all these just to point. Yeah, let's see what we got here. So we're gonna pop over here, run include ifs.jl. And let's see what happens if we do mirage fractal.png. Okay, this looks identical to what we had just a second ago. Like there is absolutely no difference. Except, is there a difference? Is there something that I'm missing here? Let me try removing this linear. Oh, final point equals point. Oh, not what I meant to do. Maybe, I've got a feeling that maybe there's something we can do. So let's remove that linear transformation at the end here. Let me take a look at this linear guy. Linear, 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 I understand. Nope, that's what I want. 0.5 times c. So c is our random constant that we're multiplying by. So let's pop up. And here's our linear there. So let's multiply by a stronger number. Let's multiply by 5. Include ifs.jl. Oh, that's because it has to be 5.0. Include ifs.jl. And let's give this guy a go. Mirage fractal.png. Ah, see, that made it a lot bigger. So let's try making it a lot smaller. I think maybe all we're doing is scaling this. Maybe that's all this guy does, which is fine. There's no problem with that. It's just, I was hoping for something a bit cooler, you know? So we have the mirage fractal.png. I guess we can perform successive transformations on this. Like we could perform a bit of a swirl and then a bit of a linear guy on top of that. But let's see what happens. What if we do a sinusoidal and then we do a linear? No, I feel like, okay, well, let's just see. Yeah, all we're doing is scaling this. So we do definitely want to scale it, undoubtedly. So let's scale this to 0.2, since I know we're going to want to scale it anyway. And now let's just take this final point and let's put it through a sinusoidal guy in here. Let's just see what happens if we try that. There's a lot of experimentation in here, and I do kind of apologize for that. Final point, and we're just going to read the final point in here. Okay, so let's pop over here. Let's do include ifs.jl, and let's see what we got. And there we go. Mirage Fractal.png. Okay, let's make the bounds slightly smaller here. Let's G down here. Oh, hello. Come on. G down here, and let's change the bounds to... we'll do 4x4 again. No, let's do 2x2. And let's see how this goes. ifs.jl. And when that finishes, we're going to try Mirage Fractal.png. Okay. Getting there, kind of. Is there a reason why transcoding hasn't been on for the past few streams? Oh, shoot. 1 second. Let me try something. I think my settings are really high then. Stream output. Yeah, let's change this to 2000. Apply that. Okay. I'm sorry about that. I didn't realize... Yeah, so I don't know how anyone was watching my stream at all. Because honestly, that was insanely high. Yeah, shoot. Okay. My bad. The reason it's just not on is because my stream's not popular enough. That's why. Like, that's the only reason. There's nothing else I can do about that. Dang. Like, the only reason I became an affiliate to begin with was so that I could have the like, transcoding options on my streams. But I just, apparently, am not popular enough for that. Hey, Ultra Hal, how are you? Okay. So here we have this guy. It's kind of sort of closer to what we want. So let me see. What else are we looking for here? Let me try... we could try a bit of a swirl in there, but I don't think the swirl is going to help. I think the swirl is just going to hurt us in the end. I'm not exactly sure why the sinusoidal guy ended up flipping us either. I have no idea. Yeah, I don't know. I don't know any of this. So let's go ahead and check this out again, and let's see what else we can try. It looks like we might want to try this blade variation here. So I might go ahead and implement this guy. So I couldn't care. Well done and bravo. That wasn't exactly what I meant when I wasn't griping the not being popular thing exactly. I guess in some ways I was. So let me go ahead and add this blade variation in there. And let's see what we need here. So it says X and Y. What's a psi? What is a psi variable that we're talking about here? Also, what is R? And what is V45? I don't know what any of those mean. What's V44? Oh, I see. Oh, no, I don't see. Nope, I don't see it all. I think I think the blade one is the one that we want to implement. So let's go ahead and try to implement that, because that gives it a slight swirl, and this might allow us to just kind of like combine some of the Barnsley Fern points together, kind of smear them together, so that we can get a better, like a better image in the way. Does that make sense? Like just kind of, more, I don't know how to put it, but more like, I don't know, just tree-like, you know, because this looks a lot like what a Christmas tree should look like, you know. The V might be a constant. Could be. It's going to be X times the cosine. But what's the psi? That's the question. I don't know what the psi is here. They have the psi a lot in these guys, so maybe I'm just missing some sort of standard notation. I'm looking through all these guys to see if they define what psi is at any point in time. Nope. Nope. I'm just looking through them all, seeing if there's something in there. Yeah, I'm not seeing it. I think I missed it. Yeah, I'm almost positive I missed it. I don't know what it means. Yep, no idea. Pretty clear they mean V is a variable for version number. Why they did it is beyond me. Well, sure, but yeah. Yeah, I have no idea what psi means. That is that's a bit of a pain. Because like it's a capital psi too. Like I feel like it's something important. But I don't know what they're trying to get at. Psi is a random variable that uniformly distributes the on the interval of 0 and 1. Ah, okay, I see. Okay, there we go. Gamma is a random variable that's either -1 or 1. Psi is a random variable that's uniformly distributed. Oh. And the trunk function returns the integer part of the floating point value. Okay, so let's go back and check out that blade function again and see if we can figure out more, figure out exactly what it is that it's saying, and then we'll see if we can implement it. Oh, now that's interesting. Huh. I guess... Did you see how that was wait. Did you see all the points being drawn on that? Apparently these are being drawn like in the PDF itself. Like the PDF, it's not just a PNG image superimposed onto. Apparently like they have all the points defined in the PNG or the PDF itself or something like that, which is interesting. Okay, so let's see. We have cosine of psi r v45. The recursive implementation of this v45 guy is kind of weird to me. And then r is also a bit weird. But I think finding r is not so hard. I think it's relatively easy to find r. Yeah, I'm sorry about the transcoding options, guys. I kind of realize now that no one could possibly have been watching the stream because I was streaming at too high of a bitrate because I needed the high bitrate for some other stuff because I have to use OBS to capture some stuff for the video. So I have to use an incredibly high have a incredibly high bitrate for that too. Yeah, it's not that it... So I'm sorry if you guys are running into issues with that. I kind of realize now that there probably were quite a few issues with that. Okay. Where are we? We are over here. Oh, did you guys mention this earlier? I might have missed it. I apologize for that. To be fair, though, like, again, the fact that Twitch can't provide transcoding options to all the streamers is kind of a big pain in the butt. Like, again, the main reason, if not the primary reason I became affiliate was that, was so that I could have transcoding options. And the fact that I don't have consistent transcoding options really does kind of drive me bonkers, because that was the whole reason I did it. Makes sense too. We didn't mention it. Yeah, I kind of wish... Yeah, okay, that's fine. Okay, so we're going to do V45. Yeah, I don't really know here. Didn't realize until a few minutes ago. Yeah, okay, that's fair enough. I've got a feeling that would explain some of why the viewership is so low for today, but that explains why it's been low recently, actually. Okay, so I have no idea how to implement this guy. I think I'm just going to have to go and figure this one out. So what I'm going to do is I'm probably just going to go ahead and close the stream here since I've got to prepare for the power outage later today. So let's see. It's 6:46 a.m. my time. I've been streaming for an hour and 46 minutes, but I think this is probably a good place to close it. So we kind of have an idea of where we're going to go. We have the Barnsley Fern, and I think the idea is that we're going to perform small scale like manipulations of the Barnsley Fern until it's more Christmas tree like. But honestly, I don't really know how to go from there. Yeah, so I'm gonna have a power outage from 10 o'clock to 4 o'clock today. Basically, I don't know. They do this power outage like once every few months or something like that. I don't exactly know why. They need to like I don't really know how to put this, but they need to like cycle through the power. I don't know what the deal is. But the power's out for about 6 hours today. So my plan is to get the video uploaded, but not like any extra features or anything like that. And then I also want to, oh, thanks Brad, so much for following, really appreciate it. And let's see, my other idea would be, here's my submission. Yes, I need to work on the algorithm archive and need to work on the video today, so I'm planning to work on that in the office. Yeah, see, that looks pretty good. How the crap did you do that? This looks like Sierpinski triangles, and then you basically have a whole bunch of successive Sierpinski triangles. It's way better than whatever I have. That's actually really good. I have no idea how to add these guys together. Ah, dagnabbit. Yeah, this is way better than what I was going to get. How did you get the transformation? No, we're still working on the cow drawing, and we've got a lot of stuff to work on. It looks like we'll be working on the Christmas tree fractal drawing stuff for the week, and we'll see how this goes. But yeah, that looks pretty good. I'm a fan. I don't know how you got... Yeah, so it's a successive number of Sierpinski triangles put together into a Christmas tree form. That's the idea. So, it's pretty good. I'm a fan. But I have no idea how to, how you specifically got, like, the two of them superimposed, so you had, like, one here, one there. There's a lot of stuff here that we need to do. Oh, this isn't mine. This is... Foldster did this one. I think you had to have done a chaos game, right? So I think the idea... Hey, T.S. Jost. You have a function that dictated what the next attractor can be from the last attractor point? Yeah, this is true. Okay, so I think we need to figure out what we're going to do. I think this is a good place to close stream. We will... Unfortunately, I probably won't host anyone at the end of stream. I'm probably just going to head out. So I think this is it for the day. We'll be back tomorrow where we do a GPU stream, which has been a while. And then I guess we'll work on this Christmas tree thing over the week. I honestly don't know if we're going to be able to do a fractal Christmas tree that is good as this one. It's 2D. So we'll kind of work on this. I don't know. I don't know. This didn't turn out the way I was hoping it would turn out, but that's okay. You know, things don't ever work out the way you want it to work out. So we'll try to figure out how to make this work, and then we'll go from there. How can you wake up at 5 a.m.? I don't know. I'm always up at 5 a.m. Anyway, so that's it for now. You make it so the top point isn't biased, but the leaves go to only leaves, and the stem goes to only stem. Yeah, okay. I think I see what you're saying. Okay. So I think that's it for the day. Thank you guys so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, when we do the GPU stream, and then after that, I guess we'll be spending the upcoming week working on the fractal Christmas tree that we want to do. So thanks guys so much for coming in, and I will see you next time. Bye guys.